In this video, we will discuss the concepts of theoretical yield, actual yield, and percent yield. For a chemical reaction to occur, reactant particles must collide with each other with enough energy and the correct orientation. In reality, not every collision is successful. Because of this, many chemical reactions do not go until completion. Sometimes neither reactant is consumed completely. In addition, some product may be lost during transfers between containers, filtration, purification, or simple spills and other laboratory mishaps. The term yield refers to the amount of product that is produced. The theoretical yield is the maximum amount that could be formed according to stoichiometry. It assumes that the limiting reactant is completely consumed and that the reaction proceeds perfectly with no losses at all. This value is always calculated. The actual yield is the amount of product that is actually obtained during the experiment. Unlike the theoretical yield, the actual yield is a measured experimental value. We can compare the actual yield to the theoretical yield by calculating the percent yield, which measures the efficiency of a chemical reaction. The equation for percent yield is equal to actual yield divided by theoretical yield times 100. We have to multiply by 100 to convert this decimal value into a percentage. Since the theoretical yield represents the absolute maximum amount of product that could be formed, the actual yield should always be less than or equal to the theoretical yield. Therefore, a reasonable percent yield is any value that's equal to or less than 100%. A percent yield that is greater than 100% is not physically reasonable. It usually indicates that the product contains impurities, such as excess water, or another source of additional mass. But it may also indicate error in the measurements. Let's look at an example. Suppose 113 grams of aluminum reacts with 279 grams of Fe2O3 and produces 173 grams of iron. The balanced chemical equation is 2Al plus Fe2O3 produces Al2O3 plus 2Fe. This is the same thermite reaction we analyzed in the previous video. From our earlier calculations, we determined the theoretical yield of iron is 195 grams of iron. The problem tells us that 173 grams of iron was actually produced. This is the actual yield. Now substitute these values into the percent yield equation. 173 grams divided by 195 grams times 100 gives us a percent yield of 88.7%. Now try this practice problem. Without proper ventilation, carbon can react with oxygen to form carbon monoxide. The balanced chemical equation for this process is 2C plus O2 produces 2CO. Suppose 40 grams of carbon monoxide is actually produced when 67 grams of carbon reacts with 30 grams of oxygen. The 40 grams of carbon monoxide is the actual yield. Before calculating the percent yield, we first need to determine the theoretical yield. Since quantities of both reactants are given, we need to begin by identifying the limiting reactant. Calculate how much carbon monoxide could be produced from each reactant separately. If all 67 grams of carbon react, the calculation predicts 156 grams of carbon monoxide. If all 13 grams of oxygen reacts, the calculation predicts 52.5 grams of carbon monoxide. The smaller value is the theoretical yield, 52.5 grams of carbon monoxide. Oxygen gas is the limiting reactant. Now calculate the percent yield. 40 grams divided by 52.5 grams times 100 gives us a percent yield of 76.2%.